Good afternoon, everyone. Good evening, good morning, wherever you are located to attend this webinar. Welcome to the fourth webinar of the sixth joint training in atmospheric composition, jointly organized by the European Center for Medium Range Weather Forecast with the Copernicus Atmosphere Monitoring Service, the European Space Agency, and the European Organization for the Exploitation of Meteorological Satellites. Those who have joined the other webinars, some of you already know me. I'm Christoph Schröder from the University of Malaga, your moderator of this session. Before introducing the speaker of the session, I would just like to refer to the text that my colleague Michelle just copied in the chat channel with some housekeeping rules. Above all, I would like to highlight that we're going to have now this presentation of 45 minutes, followed by 10 to 15 minutes question and answers. You can post your question in the question and answer section of the Zoom call, from where we will pick then 4 to 5 questions and address them to the speaker. But back to the webinar session. We have heard so far over the last couple of days about principles of remote sensing, an introduction to modeling and forecasting, as well as basics of data assimilation. And now I'm delighted to introduce you to Henk Eskes, who will talk about another component of analyzing and assessing atmospheric composition, which is evaluation and validation, specifically evaluation of models using Earth observations. Henk Eskes is a senior scientist at the Royal Netherlands Meteorological Institute, and his research focuses on the composition of atmosphere, specializing on atmospheric chemistry modeling, chemical data assimilation, and satellite observation of trace gases in the atmosphere. He's strongly involved in the Copernicus Atmosphere Monitoring Service and the coordinator of the CAMS Global Validation Contract. He's also the product lead for the NO2 product of the Tropomi spectrometer instrument on the satellite 5P satellite. So the best position to provide now this talk about validation and evaluation. Henk, it is a pleasure to having you. The floor is yours.
Yeah, thank you very much, Christoph, for this introduction. So I don't have to introduce myself anymore. Good afternoon, everyone. So indeed, as mentioned, so I will follow on from modeling and data simulation to evaluation and comparing model outputs and outputs from data simulation systems with observations. And in particular, in my talk, I will focus on how this is implemented into CAMS. So evaluation is an integrated component of the whole CAMS system. And so what I will explain to you is how this evaluation is implemented in CAMS, what kind of data sets we are using, what kind of measurement data sets, and also what kind of products of CAMS we are evaluating. And as mentioned by Chris, I'm coordinating the global validation activity. So I will focus a lot of my talk on results from the global validation activity. But there's also there's also a similar activity also for the regional component of CAMS. So let me start the presentation, if I can move to the next slide. By a very quick CAMS system overview, just one slide. You've heard already, I think, not very extensive, but you already had some introduction of what CAMS is doing and what CAMS is for. So this slide is a sort of a high-level overview of the CAMS system. So within the box, we have two components. So CAMS has a big global component and a regional component. The global component is implemented at ECMWF, and it's integrated in the IFS system of ECMWF. So IFS is well known for the weather forecast, providing these high-quality weather forecasts for the world. But this IFS system has, in the past 10-15 years, been extended and is now including inline code to model also aerosols, reactive gases, but also greenhouse gases like CO2 and methane. And it's providing forecasts, daily analysis, and also reanalysis for these components. Within this CAMS global system, embedded is our regional air quality forecasts, and those are based on an ensemble of even 11 regional models. And the main product there is the ensemble forecast of those models together. The CAMS global is also assimilating a lot of data, so it's not only a model forecast, but it's a data simulation system which makes use especially of satellite data, and that has been explained by Antje Innes earlier. While for the regional CTMs, the main target is the air quality at surface level in Europe, and that's mainly assimilating. So that also has assimilation capabilities, but it's more focusing on using the information from the in situ observations from the network that we have to monitor air quality in Europe. And then CAMS is providing a whole host of products, and for instance, national authorities can use the CAMS data for air quality analysis and forecast for their own countries. So that's very brief what CAMS is about. So what kind of products does CAMS and especially CAMS Global provide? So the main target of CAMS is to provide daily analysis and forecasts of atmospheric composition, so reactive gases and aerosols. And so those CAMS is providing 2 analyses every day, so with a 12-hour cycle. And starting from those analyses, it's providing 5-day forecasts of atmospheric composition. Apart from those analysis and forecasts, what's interesting is that CAMS is also providing a control run, as they call it. So the control run is basically the same as the analysis, but it does not assimilate the atmospheric composition satellite data. So it's a very good check to see how much the satellite data influences the analysis and the forecasts, and to see what's the impact of the model compared to the impact of the data simulation in the CAMS products. So that's for reactive gases and aerosols. Then CAMS is providing also analysis and forecast for the greenhouse gases, so especially CO2 and methane. Again, there is a control run, so we can again check what's the impact of the satellite data on these forecasts. And CAMS is also providing high resolution forecasts. So the normal analysis are done at 40 kilometers resolution, but the high resolution forecast really go a factor of 4 higher in resolution, but there's no data simulation involved there. Then a very important activity of CAMS is to provide global reanalysis. And there are 2 reanalyses, one for reactive gases, aerosols, and one for the greenhouse gases. And both reanalysis start from 2003, and they go up to basically today. So it's sort of a delayed mode product. It's running almost real time. And again, also these reanalysis also have control runs, so we can again check what's the impact of the data simulation on those reanalysis. Then within the code of IFS, so IFS Compo is the composition part of the IFS code. We have 3 flavors. So the main flavor which we are looking at is based on chemistry, which comes from originally TM5. That's the CB05 code for the troposphere, which is combined with the Basque code, which is used for stratosphere chemistry. But apart from that, there are 2 other flavors of the model, and One is based on chemistry, which was taken from the EUMETSAT model, and one on chemistry taken from the Mokage model. We don't look so much at those flavors, but that's also, those are still being developed, and so they give the possibility for sort of ensemble evaluations within IFS itself. Then a very important thing for the validation is to evaluate upgrades of the IFS compo system. And that's something that we do basically once a year, because IFS and also the CAM system have upgrades at the same time, and those upgrades typically occur every year. The latest one that we evaluated was cycle 48R1, and I will talk about that more in my slides. And then also to mention is that, of course, there is quite an active development of the IFS compo model and also the data simulation parts of IFS. And there's a lot of development test runs also for that. Again, those are not the main target of the validation activity within CAMS, but sometimes we also look at some of these test runs and evaluate them against independent observations. So quite a lot of different products on the global side. In total, about 10, order 10. So quite a lot of things to look at and to evaluate. And on the European side, we have a similar number of products. So again, we have daily analysis, forecasts, and of reactive gases and aerosols. And there's also reanalysis happening on a yearly basis. And as I mentioned, currently we have 11 models contributing to the CAMS ensemble, and the regional air quality ensemble, and the models are mentioned here on the slide. And that also delivers quite a lot of different products. So we have order 40 analysis, forecast, and reanalysis products. Okay, so what are the data sets that we compare with? So as I mentioned, CAMS Global is using satellite data to optimize the concentrations in the forecast and the analysis. So what we want to do in validation is to see what kind of independent observational data sources we have to evaluate those analysis and forecast products. And basically you can sort of split them up in different groups. So we have measurements from the surface, first of all, at the bottom. So we have ground-based in situ observations, and a lot of those are for air quality regulation purposes. But also we have remote sensing observations from the surface, and the LiDAR that you see there is one spectacular example of how you can measure above surface concentrations from the ground. But there's also many other techniques in the UV and in infrared, like FTIR measurements, which are used. Then there's also regular ozone sonde launches, which is shown on the left of the picture. But we can also have observations from moving platforms like ships. We also make use of routine airplane observations, as I will show a few examples in my talk. And we also make use of satellite data. So those are the main sort of groups of data sets that we use. And of course, it's very important that we make use of existing networks which collect data sets from different stations and also provide a uniform quality control approach. And important networks for us are the WMO GAW, who is taking care of a global network of observations. ICOS, focusing on the greenhouse gases. IAGOS is the routine aircraft measurements that I mentioned. NDAC is this network for atmospheric composition change. And that's a global network of sort of super sites with many different instruments. ACTRIS is a European activity collecting surface measurement, but also LiDAR measurements and ceilometer measurements. The AeroNet is very important for aerosol evaluations. Again, remote sensing from the surface, and we have EEA. So what are the targets for CAMS? So for reactive gases, the main gases that we look at are ozone, and not only troposphere, but also in the stratosphere. Carbon monoxide, which is a long-lived trace gas traveling all around the globe. NO2, an important precursor for gases and for ozone. Formaldehyde, SO2, and more recently, we also look at stratosphere composition. For aerosols, there is both optical properties, so the aerosol optical depth is an important one, and also the angstrom exponent, which is coupled to, which is linked to the aerosol optical depth. Then we have also surface concentration, so particulate matter. So we have PM10 and PM2.5 from surface networks that we look at. And for greenhouse gases, we focus on CO2 and CH4, again, with in situ and remote sensing. In total, it's quite a lot of data that we handle within the CAMS validation work. So we have about 65 observational data sets to deal with and to compare against the CAMS products. What's also important to know is that CAMS is really an operational validation activity. So basically, we want to have data available within a month after measurement. So it's sort of, we are really looking for real-time observations. And CAMS has a set of contracts with the parties, which are shown on the right, to make sure that we get those real-time observations, and we also have good quality observations. Okay, so again, a similar sort of overview. So you see the CAMS products in the middle, and so the data sets that we use are satellite data, satellite trace gas observations in troposphere and stratosphere. So Tropomi on Sentinel-5P is one data set which is used heavily within CAMS. But we also have GOM2, which is providing trace gases and ozone. MOPIT, which we mainly use for carbon monoxide. IASI, which is providing various trace gases. And also SAGE-3 as a monitor for the stratosphere. Then also LiDARs play a role. Recently, EarthCare was launched, and we are really excited to see the LiDAR products coming out of EarthCare and to use that for validation as well. But we also have the surface LiDARs, so EarlyNet and Actris, which are taking care of that. Then for aerosol optical depth and angstrom exponent, the AeroNet is a key network with many stations worldwide. Then we have surface concentrations, basically for air quality purposes. And we have the networks in America, US together with Canada, and in Europe, of course, and also in China, which has now a very extensive network, and that's what we use for the validation. For greenhouse gases, we have ICOS in Europe, who is gathering a lot of surface data around Europe, and that's what we are using. Routine aircraft, I already mentioned, is the IAGOS program. And then also we have other surface remote sensing capabilities, like the Brewers instruments and also the Pandora instruments, which are providing trace gas observations. For greenhouse gases, one really key network is the TICON network. Those are really very high-end, very capable FTIR instruments which measure CO2 and methane from the surface and are an important source for validation. And then we also have ozone sondes and balloons that we use for ozone profiling. Another way to look at the data sets is by listing the species and then show which kind of data sets are assimilated, and that's the third column, and which kind of instruments, which kind of properties are available for validation, and which kind of networks are used for the validation. First of all, what you can see is that CAMS is focusing on aerosol, especially the optical properties with MODIS and BMAP and VERSE as input data sets. It's focusing on ozone, mainly stratosphere and total column, with many different input data sets from different sensors. Carbon monoxide coming from EASI, MOPIT, and TROPOMI. NO2 coming from TROPOMI, GOM2, and SO2 is used also from TROPOMI and GOM2 at the moment. And then we have CO2 and methane measurements from GOSAT and EASI, which are used for the assimilation. Now then, if you move to the last column, what's interesting to see is that basically what we want is that all the assimilated species, we also have good validation data. And as you can see, that is the case. So I will not go through all the different acronyms here, but that's an important conclusion. So basically, for all the really strongly forced components within the system due to data simulation, we can also have validation information. In total, I mentioned sort of order 60, 65 data sets that we work with. And of course, the aim is to really make use of all the good high quality observations which are available worldwide within this activity. So it's quite a major task. So I mentioned basically the number of comparisons is the number of products times the number of observational data sets. And then you end up with something like 500 comparisons. So that's quite a big task. And also it's an operational approach. So what we do is we repeat our validation activity every 3 months. And we give updates of validation reports every 3 months. And that's for CAMS Global, but also for CAMS Regional, the efforts are sort of similar order of magnitude. So this is, of course, not something I do myself, but it's implemented by a team of 12 partners. Some 30 people are involved in the CAMS validation. So a lot of the credits, of course, go to all these partners. And I didn't list all the names, but it's, of course, important to realize that all the work is done by many, many people contributing to this activity. Okay, I already mentioned we have a lot of observations that we deal with, but we are still looking for new observations. So one thing I mentioned is, so the service networks are from America, Europe, and China, but there's still a lot of gaps there because we don't really have a lot of information from South America, Africa, and also Asia is a bit sparse. So at the moment, we are investigating which kind of data sets we can use. And for instance, the data set from Chile in South America is something that we use operationally at the moment. But we're extending to other data sets like Brazil, Japan, South Korea that have good networks, Taiwan. So those are data sets that will come also into the activity. And also on the front of satellite data, there are big advances. In particular, we now have geostationary satellites from GEMS and TEMPO are providing observations over Asia and South and North America. And those are very interesting data sets that we also want to take on board. And furthermore, we also make use of campaign data, and that's especially to evaluate the reanalysis products, because they are not available real time, but they become available after 1 or 2 years typically. So those are all used especially for the reanalysis purpose. So it's also interesting to look at the CAMS validation activity in terms of timescales. So we go from real-time activities, which is sort of within a couple of hours after the present time. Then we have what we call near real time. Well, the definition of near real time matters a little bit on who you talk to. But that in this talk, we will call near real time within typically a few days. And then we have a posteriori, and that's the validation reports I already talked about. So we need data to be available within 1 month. And then we can also do final analysis, typically after a year or more. So those are the main timescales, and I will go through them one by one. So let's start with this real-time application. So that's based on really for concerning quality control. Of course, you cannot do that manually, but you have to do that fully automated. So we have automated filtering and flagging procedures, and typically it relates to the data simulation, because data simulation likes to have the data within a couple of hours after sensing, so it can really provide good quality forecasts. So for this purpose, ECMWF has set up a data simulation monitoring website, and yeah, it's interesting to go to this link that you see there, and you can check for yourself. So it's providing information about what kind of data sets are used by CAMS, and also providing statistics about the difference between analysis and forecast compared to the satellite data products that are used in the data simulation. So then focus on the second column, which is about sort of near real-time applications within a couple of days. Again, for quality control, this is basically building on automated procedures. And this is used within CAMS for verification purposes. And yeah, partly also for data simulation for delayed mode data simulation purposes. What we do there is we are providing automated comparisons between the CAMS products and the independent observations on a daily basis with daily updates. Yeah, quite some of those comparisons are basically available after a few days. So let me show that. So we have set up very extensive validation servers within CAMS. The first one is the global evaluation server, and you see the link at the bottom of the page. This is really a very rich and flexible source of comparisons. And basically all the data sets that we use in the evaluation are also shown on the website. So you can on the left side of the slide, you see several examples. So comparisons with the Aeronet AOD, and you see all the stations of Aeronet there, and you can click on individual stations to get the time series for those stations. But then also things like CO profiles from the aircraft measurements, surface observations like surface PM, also satellite observations are shown on the server, and comparisons. And also, also graphs where you have time versus latitude, basically. So you get an overview of the validation results on a global scale as a function of time. A second validation server that we have developed a bit more recently is what we now call the CAMS Global EQC server. And the link is shown again at the bottom. And during the on-site tutorials, you will learn a lot more about this server, and you will start to play with the server. This is a very interactive tool, which is very nice to use, and you can click on any detail within the plots, and you get expanded views and time series. If you do so, and you can create all kinds of averages of statistical quantities with this tool. So the previous one was a bit more focusing on the real-time verification, but this one is focusing more on the reanalysis and also the CAMS upgrades, and has separated experiments for those two applications. And the server is developed by Met Norway. And one nice aspect here is, for instance, these heat maps, which are available within this system, where you can look at different CAMS configurations, for instance, new upgrades of the CAMS system, and you can compare them to the previous upgrade. And then in the vertical, you see different observational data sets. And in this case, the colors give an indication of the biases that we see for the different data sets that we have. So ranging from aerosol properties to NO2 and ozone in this case. So in this way, you have a very quick overview of where sort of a new version of the model is improving over the old version. And you can also compare the control run without data assimilation with the assimilation version and see what the impact of the assimilation is. Okay, the third pillar is the a posteriori evaluation, and that's basically the validation reports, which we produce every 3 months. And this is much more manual, so it's really we are looking at all the validation results which we obtain, and we give an expert opinion about this. And so in that sense, it goes from verification to validation. And yeah, so this is the latest report which we have produced. We are now working on the March to May report for 2024, but that will become available in a few weeks. So it's quite a big report, about 200 pages, and lots of, and also almost 200 figures. But it also tries to summarize all the results, so it has a standalone extended summary, and also things like scoreboards where we bring all the data together, and it's a bit like the heat maps that I showed before, to have a quick overview of the performance of the CAMS system. And then the last pillar is a final evaluation, which is basically looking at the reanalysis of CAMS. And there we can really use older data sets. So typically observational data becomes available after 1 or 2 years as a final data set, which has been evaluated by experts and validated data. So the data is different from the near real-time data. But for the rest, yeah, we can do similar evaluations, and those kind of data sets are mainly used to evaluate the reanalysis products of CAMS. And again, we produce reports. So we have yearly validation reports for the reactive gases and aerosols. And for the reanalysis, I also provide a few key references here on this slide. Similar thing we do for the greenhouse gases, so that we also provide yearly updates of the validation for the reanalysis product. A few examples. So on the top, you see the long-term evaluation of the reanalysis with the AeroNet aerosol optical depth data. And what you see is that well, it's not very clear on the slide, but there is a red line, which is the reanalysis. And basically that red line is quite nicely following the AeroNet data. So there's a good correspondence between those. And also the slow negative trend that you see in AeroNet is well reproduced by the reanalysis. So that's looking very stable and a very useful data set for trends also. Then we have tropomi NO2 or NO2 evaluations over a long period. So this is not based on tropomi only, but also on SCIMACI and GOM2. And that's showing one dilemma that we have within the reanalysis. So because we fix the emission data sets in the reanalysis, we see that, for instance, the trends that we have over China, which was first increasing rapidly in NO2, but then was cleaning up. So they had a lot of policy measures taken around 2012, that time, and then we see a clear decrease. And yeah, then it's really sort of, you see that the assimilated data is sort of becoming, getting a little bit of conflict with the emission data sets, and you see that the reanalysis does not fully capture the trend, the downward trend after 2012. Another interesting comparison is the one with ozone sondes, which is shown on the right. And there the red line, so that's showing the bias in the pre-troposphere mid-latitude ozone concentrations. And what's interesting is that the CAMS is assimilating stratosphere profiles and also total column information. And with that information, it seems to be able to improve compared to the control run, which does not assimilate data, which is in blue, where you clearly see a strong seasonality and negative biases, which are strongly reduced in the reanalysis. So a few examples also for the greenhouse gases. Comparing, so that's the so-called EG4 reanalysis, the fourth reanalysis for the greenhouse gases. And on the left, we see comparisons with the TCON, so a very important network for total columns of CO2 to evaluate those. And on the right, you see the comparisons against surface concentrations, ranging from the top is the sort of close to the North Pole, and the South Pole is on the bottom. So you basically get a latitude cross-section versus time. And what you get from this is that there is a clear seasonality. So that's saying something about the modeling of the biosphere in CAMS. And also we see a trend, which is maybe related to the data simulation aspects. A key reference for the greenhouse gas reanalysis is given on the slide. That's the paper by Ana Agusti Panareda from last year. Another thing that we do in CAMS is evaluate major events that happen in the atmosphere. And this is done in collaboration with the CAMS Weather Room, with Mark Barrington, who is leading that and who is also organizer of the school. So yeah, and there's different, I will not go in detail, but and the slide is a little bit crowdy, but we look at major dust transports. So sometimes even in the northern parts of Europe, we have dust from the Sahara, which is influencing the weather, and which is you can even observe by the eye. Sometimes major volcanic eruptions is something of interest that we monitor and look at, and we look at with independent data, and especially also with satellite data. We look at the quality of the CAMS forecasts in those cases. A very prominent aspect is the North American fires of last year, 23. Which were enormous, and in the bottom you see the total fire carbon emissions, and the red line is 23, and you see that it's fully out of scope compared to the normal climatological fires that we had in the past. So yeah, things are changing. And then, as I think is more or less the last part of my talk, is I also want to mention that we evaluate system upgrades of CAMS. And so basically CAMS is upgrading every year. The last system cycle upgrade was 48R1 in June last year. And the next one will be in November 24, and that's called 49R1. And then what we do is we evaluate the current CAMS operational system with the so-called E-suite, which is a parallel run with a new configuration, but in fully operational mode, so it's providing analysis and forecasts in the same way as the operational system is doing. And we look at the differences between the two and evaluate if this upgrade is really improving the performance of CAMS or not. So on average, we would like to have basically an equal or better performance concerning different statistical measures like bias, root mean square errors, and correlation. But for specific cases, there can be maybe some negative excursions also, but they should not be too large. So basically, those are criteria that we use, and also provide an advice on whether or not this is a useful upgrade. So the last one was a very major upgrade because it was collecting a couple of years of development work within CAMS, and lots of things changed in the CAMS system, the modeling and the data simulation. And we published this evaluation recently in a paper in ACP, which was published in August 24. And you see that there is a lot of co-authors there, many people involved in this work from the modeling side, data simulation side, but also the evaluation side. And basically, what we produced there, we summarized all the results in this scorecard, which you see on the right. And basically when the color is green, so on the vertical you have all the different data sets that we use for the evaluation, for the aerosol parts, for ozone, carbon monoxide, NO2, formaldehyde, UV, and then things like optical depth of aerosol, angstrom exponent for aerosol, and also the PM. And the column on the right gives sort of the relative score. So if it's green, basically we see that CAMS is performing better compared to the previous system, so the operational system, which was in operations before. That was cycle 47R3 in this case. If it's red, we see a slight, or if it's light red, then we see a slight degradation compared to the previous system. And if it's dark green, then we see really a very substantial improvement for a few of the properties. But basically, we showed that for 83% of the evaluations, we have a neutral or improved performance. And only 17% indicates that there is a degradation or a slight degradation. So that basically shows the overall success of this major upgrade that CAMS launched in last year. A few examples. I don't have a lot of time left. So one thing, so the ozone columns. So if we look at the ozone evaluation, we see that the new configuration is performing better. If you look at the lower panels, you see that in the old system we had some artifacts near the tropics, and those have disappeared in 48R1. So that's a good sign. Another example is carbon monoxide. So there a lot changed in the data simulation because now we make use of Sentinel-5P tropomi carbon monoxide, and also we make more use of EASI data and less focus on MOPIT. And you see that very clearly in the validation, where now the evaluation against MOPIT has become worse because MOPIT was the main source of data simulation in the past, in the old system. But for EASI and for tropomi and also for other validation sources, we could show that it was really an improvement, and we get better scores for CO. So that was an important step. Also, emissions have changed drastically. So I have to wrap up my presentation, so I try to be quick. So we see that, for instance, this downward trend in emissions in China, which I mentioned before, is much better described in the new emission data sets, and that improves the score for, and especially the bias for NO2. And the really important big new thing is that we now, in 4801, we have this full stratospheric chemistry system, which was not in place before. And we see that that improves also the scores of ozone itself. And then we can also look at many different components in the stratosphere. So in this case, it's a combined plot showing water vapor, the N2O, greenhouse gas, methane, but also things like CFC11, which we can measure with satellites, NO2 and CLO, which is a measure of chlorine activation and breakdown of ozone close to the ozone hole in particular. So we can look at those species in detail, and that's really a new activity compared to what we did last year. Okay, and that brings me to my summary. So I think I'm not doing too bad. So I gave you a flavor of the evaluation and quality control that we do for the CAMS global products. So it's the basic aim is to provide information on the quality of the CAMS service products as they are provided on the ADS, on the data store of CAMS, to the CAMS users with summary for sort of more impatient users, but also with very detailed results for the more advanced users of the CAMS products. One thing I would like to note also is that the validation team, as validation team, we have quite strong links with the providers of measurement information. And also we like to keep some distance from the ECMWF team and the model developers, so that we can really give an independent assessment of the quality and not biased by enthusiastic stories about new developments in the CAMS system. But it's important to keep a little bit of distance also with the developers. We evaluate global analysis and forecasts. We also evaluate the upgrades, and I showed quite some details of that. And we also look at the reanalysis products of CAMS. And also to mention that a similar type of activity also exists for the regional CAMS air quality services. So I didn't show any results there, but you can also find those kind of evaluation results on the CAMS site. So CAMS data is available through the data store, as you have heard probably a couple of times already. Then I mentioned the 2 validation servers, and you're very welcome to have a look at those and experiment for yourself and see what kind of comparisons we provide. And you can look at your own country of interest, for instance, and move to specific locations and see what kind of measurement data is available at that location and look at the validation results for those locations. And all the validation reports are, of course, public and available on the CAMS website. Okay, thank you very much for your attention, and let's see if there are some questions.
Yeah, thank you very much, Henk, for this presentation. Very insightful, very, very comprehensive. Yeah, so for the time there's no question posed. I invite the participants to include any question in the Q&A section. But maybe let me start with one question, but also linked to the validation outcomes and the update, particularly the improvements that you have presented. Based on this latest upgrade you showed, highlighted with the improvements, there were some also red rows with degradation, as you call it. So where do you see or where have you found areas, so both also geographically, maybe also the species related, where major improvements are still needed in the CAMS system? And maybe as a follow-up to this, what do you think is needed to improve better modeling, better observations? So what is your take on that?
Yeah, I think you have to understand also where this may come from. So these data sets are very inhomogeneous and very different, have a very different nature. So some data sets have quite a sparse, have just a few sites that they look at. Instruments are different. So it's not the case. So even the difference between the instruments can already, and also the measurements themselves can have biases, and but you also have to worry, for instance, with surface data, there can be representativity issues, so that what you see at the surface is maybe not for a particular location, a point location is not always representative for a grid box of CAMS, which is 40 by 40 kilometers. So all those kinds of aspects can play a role and can lead to also biases. What I showed in particular is, of course, the case for carbon monoxide, where you see that if you look at the MOPIT data, there is a difference between MOPIT retrievals of CO and EASI retrievals and TROPOMI retrievals. They retrieve different things. So in that case, we see that with the new system, we degrade compared to MOPIT, but in fact, we improve compared to EASI and TROPOMI. So it's important to realize that if there is a red color, that doesn't mean that CAMS is getting worse, but it's also reflecting the difference between these data sets and retrievals. So that's very important to keep in mind. And that can so therefore we look sort of at a bigger picture and say, okay, 87% is improved or did not degrade. So overall, it's really a good improvement of the CAMS system, and it's really bringing us forward in getting good quality products.
Yeah, great. Thank you very much. There's a question now from Stefan. I just read it out loud. So could you please explain why the data assimilation from MOPIT in the case of carbon monoxide was switched to assimilation from TROPOMI and EASI? Also, is there a reason why all three satellites could not be assimilated at once?
They can be. What happens in the IFS system is that IFS allows for to introduce bias corrections in the data simulation. So it's not only assimilating individual observations, but it can also create information about biases. Especially you always, when you bring more than one data set together in a data simulation system, you will always see that there is an offset between those different data sets. And what happened before is that MOPIT was taken as the anchor, and other data sets like EASI were bias corrected. And what we found is if you compare to independent data, then that's not the best solution. So if you move the anchor from MOPIT to EASI and TROPOMI, which are more similar, you basically increase CO in many places, and you get a better match with other independent CO datasets, like from the aircraft or from the NDAC network. So that was an important reason to apply this bias correction on a different data set. But yeah, in general, so within the CAMS system, there is this capability to do bias corrections, and especially if you have multiple data sets, it's very important that you do so, because otherwise you will jump from one level to the other, depending on what data comes in at a certain time. And so these general biases between data sets have to be corrected, because otherwise you get degraded analysis.
Thank you very much. There's another question by Lydia, asking, are there similar sites for the regional and European evaluations?
Yes, especially, so I showed these Aeroval validation, so this global EQC server, there is a similar one, but then for the regional. So I think it's called regional EQC server, but I have to check to be certain. But you can find a link on the KNMI website. So if you go to the evaluation pages and then EQC pages, then you can find those links.
Great. I don't see any additional question. I would have just one regarding new sensors and new observation data upcoming. So what are your expectations regarding the simulation integration of upcoming Copernicus Sentinel expansion mission? So particularly talking about carbon dioxide, so CO2M, the Copernicus anthropogenic carbon dioxide monitoring. What are your expectations?
If you talk about the Sentinels, then first of all, those are a target for the data simulation. So, as I mentioned, the validation activity is looking for independent data sets. So it's looking not first of all at the data sets which are assimilated, although we also use that in our evaluations, but we are especially looking at independent data sets. So things like CO2M is really very exciting, and hopefully will bring the data simulation for CO2 especially a very big step forward. And well, the aim, of course, internationally is to use this for carbon monitoring and to also to look at what the impact of new regulations and policies on carbon dioxide in the future, and to monitor this from space, and to especially look at the anthropogenic emissions in those studies. So KNMI is really moving from an assimilation of trace gas concentrations to the assimilation of emissions, and so that's, I think, a very important development. And within KNMI, we are very much busy to set up the codes to generate emissions based on satellite data.
Okay, I think there's a bit of a follow-up question on that. So, well, linked at least by Danielle. What kind of impact will new geostationary satellites have, so Sentinel-4 and TEMPO?
Yeah, so what we have now with the satellites is that they typically have the polar orbiting satellites have a fixed overpass time. So if you look at Tropomi, it's providing a lot of very interesting high resolution information, but it's always at 1:30 in the afternoon. And with the geostationary satellites, we go to hourly observations, but then for a more restricted area. So there we now have TEMPO recently over the US. So it's looking only at that part, Northern America. Then we have GEMS already a couple of years over Asia, and hopefully soon, within, say, a bit more than a year, we will also have Sentinel-4, which is also a geostationary measurement, which provides observations with footprints which are smaller than 10 kilometers. So we can start to really see individual emission hotspots and areas with those data, but then on an hourly basis compared to once a day.
Great, thank you very much. I don't see any additional questions, so I think we're in a position to really close this webinar on time. Dear Henk, once again, many thanks for your presentation, for the replies to the questions. Thank you very much to the participants for the interest and the active participation. The series of webinars continues tomorrow at 1:30 p.m. Central European Time with a presentation about downstream services and data applications by Laurence Rouil from ECMWF. Thank you very much.